All right, so today we are starting chapter 2. We're going to work with real numbers, mostly just properties of real numbers today. If you are looking at your book, this is section 2.1 and 2.2. You should all have the notes packet in front of you. The whole front, that's all the properties. We're only going to get about halfway through the properties today. Then we're going to practice those properties, do a little homework, and then we'll finish up those properties later on. All right? Here is just a quick little conversation I want to have with you guys. If I told you to add those numbers as quickly as you can, does anyone know what a good strategy would be? Yes.
Like match numbers, so like 8 and 2 is 10, and then 7 and 3 is 10.
Okay, so you just add the easy ones like 100 and then 50
and 6.
Very good. That right there is the way most people do it when they see this. And the reason that works is because of the properties of addition that we just kind of use all the time, but we don't have fancy names for yet. I'm going to give you those fancy names today, okay? So think back to this, how you can group them in different ways, you can order them in different ways, and it's still doing the correct operation of addition, all right? The first one is the commutative property. So in your notes, you have a little table. It has this part in it, A plus B equals B plus A. This is the part you need to fill in. So you're filling in the actual number examples. I'm giving you like the formal sort of property from your book. So you just have to write this. Okay? I'm going to show you the commutative property of multiplication at the same time, and then I'll explain a little more. So the commutative property of addition states that A plus B equals B plus A. You could put real numbers in there. So 2 plus 3 equals 3 plus 2. Works for multiplication as well. A times B is the same thing as B times A. If you put real numbers in there, 2 times 3 is going to give you the same answer as if you did 3 times 2. So there's a little explanation at the bottom. The order in which you add or multiply two numbers does not affect the result. So basically, order is not important if you're adding or multiplying, like we just did on that warm-up problem we were talking about. If you want to add the two numbers at the end, go for it, okay? If you want to flip-flop two numbers because it seems easier to start with the bigger number and add the smaller number to it, that's fine too, okay? Order does not matter when you're adding or when you're multiplying. The way I like to think of this one, commutative, it makes me think of the word commute, like my drive to work, right? So I live in Columbia. So every morning I start in Columbia and I end in Belleville. In the afternoon, I start in Belleville, but I end in Columbia. See how the order's different? But I'm going the same roads, okay? So that's how I remember this one. It's like your morning commute. You start at your house, you go to school. In the afternoon, you start at school, you go to your house, same drive, okay? Of course, maybe you stop at the grocery store or whatever, but use your imagination, all right? Any questions on the commutative property? All right, here's the next one. It's the associative property. I will show you all of this and then explain. So the associative property has to do with grouping, okay, or associations of numbers. The grouping of numbers, when you add or multiply any three numbers, does not affect the result. That is a very fancy way of saying that you can move the parentheses around when you're adding or multiplying three numbers. So order of operations tells us we have to do parentheses first, right? That usually matters unless it's all addition or all multiplication, then it doesn't matter. So you could do 4 plus 3, then add the 5, or you could do 3 plus 5, then add the 4. It doesn't matter. You'll get the same thing. Multiplication works in the same way, okay? So anytime you're moving the parentheses around, that's the associative property. So all the previous examples, the things that were changing were all on the same side of the equal sign. The changes to equality, it happens on both sides of the equal sign. You'll see when I get there in a second. So the first one is the reflexive property with an X. A lot of students want to change it to reflective property. it kind of is like a mirror, same thing on both sides, like a reflection, but that's not the way I like to think of it. The reflexive property with an X, it's one thing that we're looking at, and it's on both sides of the equal sign, okay? The other property of equality is symmetric. The symmetric property says that the order that you write something equal doesn't matter, okay? You could put the A in the front, you could put the B in the back, put the B in the front, you could put the A in the back. It doesn't matter. That's the symmetric property. And here it is with numbers. If A equals 6, then 6 equals A. And then the transitive property. The transitive property involves 3 parts. If A equals B and B equals C, you can cut out the B that they have in common and just go straight from the beginning to the end. A equals C. And here it is with numbers. So if A equals 3 and 3 equals C, then A equals C. Now, the way I remember these, I have like a memory trick for all of these. The rest are a lot more boring, so don't get too excited. Do you guys see the first letters R, S, T? Which one of those comes first in the alphabet? R. Which comes second in the alphabet? And T. These are all the properties of equality. In the reflexive property, we have one thing equal to itself. So this involves one item. The symmetric property involves 2 items, A and B, just written in a different order. The transitive property involves 3 things, A, B, and C. And then you cut out the middleman. So I just remember it, alphabetical order, 1, 2, 3, 1 item equal to itself, 2 items equal to each other, 3 different items equal to each other. Any questions on that one? All right. This one's kind of strange for a lot of students. It's called the closure property. This works for all real numbers A and B. Just listen and try to soak it all in. So this is basically saying that if you take 2 numbers and you add them together, you'll get another number.
What?
And that number will be a real number. Now, the hard part is that you guys aren't really far enough in your math career to know anything but a real number. So you just have to take my word for it. There are numbers out there that are not real, and we're not going to get into it. We're not going to get into it. But we're not going to get into it in this class. Come see me as a junior, and we'll dive right in. But what you need to know for this class, for Algebra 1 Advanced, is that when you add 2 numbers together, the answer is a unique real number. When you multiply 2 numbers together, the answer is a unique real number. So basically, the sum or product of any 2 real numbers will result in a real number. It's called the closure property. So the substitution property says that putting an equal amount into an equation or an expression will not change the equation or the expression. So in this example, if you replace the 3 plus 6 with a 9, it's the same thing, okay? The substitution property. So we are now going to get into examples. So go ahead and flip to the back of the front page of your notes. We will fill in the rest of the properties chart as we continue through the chapter. So right now we're on the back of that first page, example A. We are naming the property here. So if x equals 2 and 2 equals z, then x equals z. That is the transitive property. We're talking about 3 different things all equal to one another. All right, transitive property. The properties are hard for a lot of students just because they all look so similar. So if you're like, I don't even know how she got that, Don't worry about it. Keep flipping back to that front page and try to see if you can distinguish what has changed as we described what the situation is, okay? We cut out that middleman. The first two things, or the first thing and the last thing, are now equal. There were 3 items total, transitive property. Here's the next one. What moved around? The parentheses, and that makes me think of which property? The associative property of addition, because there are plus signs. Any questions?
No.
I will not switch it.
Thank you. Can we not have a test?
So order doesn't matter in addition. R plus S is going to give you the same thing as if you do S plus R. That is the commutative property of addition.
Exactly.
These only work for addition and multiplication, so you're usually just picking between those two. If you see plus signs, put of addition. If you see multiplication symbols, put of multiplication. We don't need comments between every single example. All right, here's D. X times Y is the same thing as Y times X. Commutative property of, this time it's multiplication. All right, if you multiply 5 and 2, you'll get a unique real number. Closure property of multiplication. Closure property is the one that has the real numbers in it, okay? And part F. One of these times substitution will be the correct answer, but not yet. I was going to say, I think you're just saying it until it's correct. All right, what did we do here? Yes, you just moved the parentheses, so this is the associative property of multiplication. All right, so part G, if 4 plus 1 equals 2x, instead of writing 4 plus 1, we substituted in the equivalent value of 5, and that is the substitution property. What are your questions?
Can we not have homework?
You will have homework. You'll probably get it done in class, though. All right, so now it's switching the different sides of the equal sign, right?
Yeah.
So the order is switching, but not on the same side. It's going across the equal sign. Yeah. So a lot of students want to put commutative because the order is different. It's not the commutative property. Commutative property would be if, like, right here I put B times 2, okay? But it's actually switching across the equal sign. So that is the symmetric property. If it was A equals A, that would be reflexive. I heard someone say reflexive.
Yeah.
We're talking about two different items. So reflexive is just one if it's the same item equal to itself. Sorry, did I go too fast?
Yes. Wait.
Symmetric. All right. Same number equal to itself. That's reflexive. Good. All right, and when you add any numbers, 3 and 4 will work. You get a unique real number. What property is that? Closure property. Good. Of addition, because we're adding. All right, don't put your notes away yet. We got to summarize at the bottom.
Oh, yeah.
Don't forget. So, what did we learn today? I even started the sentence for you. Today we learned properties of real numbers. Good. All right, and then you fill out the other two, so anything that you're unsure of in a sample test question. We will continue talking about the properties tomorrow, so we're going to fill up that table, and I'm going to give you your homework right now. Any questions?